All right, this is cis256. Today we're going to talk about some hint to solve problem set 3 with recursion. So here is the problem. You're trying to solve Sudoku. Sudoku is a very popular game where you have a, let's say, x by x matrix, and you can fill in each cell with a number. And so such that each row you have unique number from 0 to 9, and each column you have unique number from 0 to 9, and each 3 by 3 we call it box has unique number 0 to 9. If your solution satisfy all three conditions, then you have a solution. So initially this board is filled with some predefined numbers and with all the empty cells numbered 0. So your legal number allowed is 1 through 9, but no 0. 0 means empty. So given each board, do you have a solution or not? We don't know, but we want to figure out using computer. So how you gonna solve this? Well, the basic idea, there's a lot of ways. One of the thing is whenever you fill in a number, and you can check if this number is a legal move. Well, what do I mean by legal? So first of all, if the cell is already occupied, then you cannot put a number, obviously. And you can only put a number when there is a 0, which means it's an empty cell. Well, you could put a number that is not the same number in the same row or the same number in the same column. So for example, if the human is doing that, I'm gonna, in this position, you can put in any number that's not 4 or 5, because there's a 5 here, and 4 here, and 4 here, and 5 here. Anything that other than 4 and 5 is legal here. Once you fill in that, the whole board is changing, and you are one step towards the solution, right? So this is legal move, and then you're gonna call this solver function again with the new guessed number in. And you continue to fill in numbers and check the legal, if this number is legal, and you move on until you have reached this step where there's no way you can put in a number that's making the whole thing legal. Then you know at some point you're wrong, and you have to backtrack and leave this empty, leave the previous things empty, and try a different number and continue until you find a solution. So this is called a depth first search, because you are going deeper into the stack until you cannot figure out a solution, and then you backtrack one step and continue with that. So having said enough, let's take a look at what you need to implement here. So I already take care of the initialization of the Sudoku class with some like the board is a matrix n by m matrix. Okay, so these are typical things, and I have a function to print the current Sudoku solver. So like I said, you need some helper function to see if you have a board with a number with coordinates, which is a pair of row and column. Is that legal? Is that allowed? Right? Okay. And then in the solver, you're gonna just do this, right? You have a 2 by 2 iterate through each row and column, double loop. Try all the possible number in that row and column, right? If this board row and column is empty, otherwise you just skip it. If one of the numbers allowed, using the helper function, then you call the solve again. If finally the solve returns a true, and you just return the true. Right? And otherwise, here this else corresponds to the for loop, and you will find another solution and backtracking again. You rinse and repeat. Okay, so let's do this solver first. Let's worry about this is allowed next. Okay, so what's the big picture here? We are doing 9 by 9, are we? Yeah, let's do a 9 by 9. So okay, so this is just a help function to load the board from the CSV file. You can take a look at this techniques. There's some caveat here. You can't do this times 0 or times 9 to repeat 0 9 times because it's going to causing an aliasing. If you change one position, we change everything. So yeah, just using this nested list comprehension will be good. All right. So let's run it first. So you can see there is a solution, no solution yet, but this is an empty 9 by 9 board first. Okay, so let's that's okay. Let's just try it. I can. So first of all, let's do a to for loop, row in range of, wait a second. Self.n, self.n. Wait, row. And column range of self.n. All right. So m is 9 by 9 for now. If not, so basically if self.board of that row and column, right, if that cell is there's a number in it. Wait, if there's 0 in it, so not 0 is 1, so you can is true. So if there's 0 in it, that means it's empty. I'm going to try all 10 numbers, 1 to 10. Okay, actually 1 to 9. 10 is not included in the range function, remember? So if, let's call it is allowed function, we haven't implemented this, but we can use this. Num, that number with the row column as a tuple with coordinates, right? If that's allowed, then we're gonna continue call the self in this is the recursion part. So we're gonna fill that row column with the number. And after that, call the solve function. And if finally solve it, return true. We only return true when everything's solved. Else, so you tried, yeah, this else is for the for loop. If you exhausted all 10 numbers in that cell, but there's no solution, are we gonna return false? No, before we do that, we're gonna clean up the row and column because it was 0, right? We're gonna this is a backtrack part, and then we're gonna return false. So this is not right. And then we're gonna return. So here, after the top, so if we exhausted all the rows and columns, and you either found a solution or no solution found, right? You can just return true. Okay, so I think that's all for the solver. Very simple solution. Now let's talk about is allowed. So is allowed. What do you do? Well, the hint says row column is coordinate, right? Get that. Find which box the number belong. How to do that? What do I mean by that? We we can use these techniques. Row is row divided by 3 and times 3. So what do I mean by that? So if the row divide integer division, this is Python integer division, right? If row is between 0 and 2, that's in the first, right? Okay, first 2 rows, or first 3 rows. So if you can see that if it's 3, then 3 by divided by 3 is 1 times 3 is 3, right? So remember, it's starting from 0, right? This is 0-based counting. So from 0 to 2, 0 to 2 belongs to the first box, right? 0 to 2, row 0, 1, 2. So that's still 3 rows. So, but 2 is less than 3, so this is going to be 0. So the row is 0. So all the box, the row is 0. I mean, the box row, right, is 0. And the column is the same thing. The C is column integer divided by 3 times 3. So with the R and C, let's check if the number is in the row. So check rows. If it's in the row, then return false, right? You cannot have the same number in a row. If number is in this list. So self.board I column. What do I mean by that? So for each column, right, in that row, so what is I? For I in range 9. Actually, self dot m, number of rows, which is 9. So basically, for I in 9, right? So basically, this is check the, let me see, check the column, right? The row is simple because you just say the self-board row, but the column you have to do for each row. The row is in that range of rows. You check the column. If that's the case, return false. So you check row, check columns. Now check the box. Let's use else if instead of if because these are mutually exclusive. Else if number in, right? So this is the box, right? So for each I, j, which is row and column, I in range of R plus 3. So why I'm doing that? Let me finish this and I can explain it to you. So check box. So basically for each box, right, 3 by 3 box, right, I want to know which, so there's like 3 different layers. Which layer in the row and layer in the column it is, right? We divide this layer into 3 by 3 boxes. So we want to know if this IJ falls into any of the 3 by 3 or 9 boxes. So for this, if the row is basically beginning of the row, which is divided by 3, right? Divide by times 3. So if anything that's within this region is row 0, and so 0 to 0 plus 3, remember 3 is not counted, so 0 and 2. So I is row number, right? Row in that 1, 3, and J in column plus 3. So if any number, so basically I pick any number and I'm gonna actually check all the number around it, right? Within the same box. So what's the characteristic of I and J with the same box that's the number I'm interested in? Well, they share the same layer and same colon layer, and then from the layer you add 3 and colon add 3. If the I and J are all in this range, right, then it's 9 by 9, then that's not allowed either. So it's in the box. So if you don't understand, no worries. You can do it one by one, but that's some tricks. I'm going to save some typing. Otherwise, it turns true. So you check the row, check the column, check the box, and they turn true. So that's it. And let's see, hey, it solved the problem. All right. And think about it. Thank you very much. Have a good day. Bye.